Hello everyone. Today our topic is train detection track circuits. And this topic we are going to cover introduction, various types of track circuits, understanding of open DC track circuit and closed DC track circuit, parameters of track circuits, functions of staggering in track circuits, various traction bonds in DC track circuits in RE area, diagram of single rail DC track circuit and name its components, advantages of Excel counter, components of Excel counter system, each card functions of CEL SSDSC. To detect the presence of a vehicle on a portion of track is known as train detections. Basically, there are two means to detect the presence of a train over a track, which are first track circuit, which consists DCTC, ACTC, and AFTC. Secondly, Excel counter, which are consisting analog and digital. Types of track circuits depending upon the power sources. First, DC track circuit, second, AC track circuits, and third, AFTC, audio frequency track circuit, also known as electronic track circuits. They are two types, non-coded and coded. DC track circuits. For DC track circuit, power source for working track circuit is DC voltage. DC track circuits are of two types. They are open track circuit, second closed track circuit. Closed track circuits is further classified into two: double rate track circuit for non-RE area, single rate track circuit for RE area. Track circuit is a device in which running rails are part of the electrical circuit. The limit of track circuit are embarked by insulation joints, and inside the territory are bonded at the rail joints for better conductivity. The occupation or vacancy of the track portion is detected by the condition of track relay. The length of the track confined within one track depends on its working feasibility. The components of DC track circuits are battery, one or two or three cells, each 40H or 80H, adjustable resistance, 15 ohm or 30 ohm, track relay. Track relay types are QT2, QTA2, QB80, and shelf type track relays. Track lead cables, that is 2 core into 2.5 square mm. GI, galvanized iron wires connecting cables to the rails with 8 SWG standard wire gauge. Continuity rail bonds to avoid the high resistance at fish plates rail joints. Insulated rail joints, block or glued joint. In open track circuit, the track relay always in de-energized condition. The track portion shows unoccupied, that is clear. Disadvantage: any failure, disconnection in the track remains undetected, which is unsafe. Advantage: power saving. Closed track circuit. In closed track circuits, the relay is always in the energized condition when there is no track vehicle in the given portion of track. It shows unoccupied. When any train or vehicle enter the given portion of track, it shows occupied. Track relay will be de-energized. The advantages of closed track circuit: any failure, disconnection in the circuit results in failure of track circuit, which is a safe side. Hence, only closed track circuits are being installed. Blast resistance is the net resistance of various leakage paths across track circuit rail offered by blast and sleepers. Blast resistance is inversely proportional to length of track circuit, and also it varies at per condition, dry or wet, of the blast and soil. It reduces with increase in the length of track circuit as leakage path in parallel or more. Rail resistance is the combined resistance of the track circuit rails and the continuity bonds at rail joints. Staggering of adjoining track circuit. In the arrangement shown above, similar feed polarities are connected to the adjoining track circuit rails. Here, failure of one of the two block joints, number 1 or number 2, can go undetected as it does not drop the track relay on either side. But later, if the second block joint also fails, both the track circuit feeds come in parallel. This is an unsafe condition which should be avoided. In the arrangement shown above, the polarities of track feed across the block joints in between are not similar, so when both the block joints number 1 and number 2 fails, both the track feeds get connected positive to negative and negative to positive with a high circulating current in between. 1 TR or 2 TR or both may drop according to the fall of track voltage, even without a shunt across. It is safe side failure. DC track circuits in RE area. DC track circuits in RE area, one rail is insulated for provision of track circuits and the other rail is left for traction return purpose to the substation in parallel with earth return path. These track circuits in which one of the two track circuited rails carried traction return current are called single rail track circuit. Traction bonds in RE area provided easy path of traction return current, ensures safety working of the track circuits, ensure safety working of person. Types of traction bonds: structural bond, transverse bond, that is staggering, cross bond, uninterrupted flow of traction return current, longitudinal bonds, continuity for flow of return current. DC single rail track circuit. Components: battery charger 110 volt by 2 to 10 volt DC. Feed battery 1 to 4 secondary cells. Fuse and link. Regulating resistance adjustable 0 to 30 ohm. Type B choke, resistance 3 ohm and impedance 120 ohm. Track lead cable 2 into 2.5 square mm copper. Track lead junction box. Track lead steel wire ropes. Transverse bonds. Block joints. Track relay ACI. Continuity bonds. Axial counter system introduction. Advantages. The advantages of axial counter over a conventional track circuits. It does not require wooden sleepers, short length track circuits which is used to suppress the counts due to movement of insulated trolleys. B. It covers a very long section up to 15 to 20 kilometers. Its working does not get affected by climate changes like flooding of track. It does not require IRJ or glue joint. Efficiency and safe working of axial counters does not depend upon various track parameters. Overview. Excel counter consists of track device mounted on the rails, track side, electronic equipment and evaluator. Evaluator monitors the count of track device. Excel counters work on the principle of counting the number of axles of the train entering and leaving the specific section. It counts the number of axles entering a section of train as in counts and the number of axles leaving the section as out counts. If the in counts are equal to out counts, then section is set to clear as it is occupied. Digital Excel counter consists of indoor component and outdoor component. Indoor components are reset box and repeater relays. Outdoor components are relay box, evaluator, and detection points. Salient features of SSDSC DACF 710P. The system consists of single section digital Excel counter, that is SSDSC units with wider relay VR and PR. Second, transmitter and receiver coils. Third, reset box. Track side electronic counting equipment. Wave type Excel detectors. Coil consists of 21 kHz and 23 kHz. High frequency phase reversal type Excel detector. Compatible with 90 or 52 kg and 60 kg rail profiles. Detection of all wheels with normal flange and diameter more than 400 mm. Track clear occupied wider relay output at both stations. Microcontroller based design with 2 out of 2 detection at each SSDSC unit. Decision based on 4 out of 4 logic for complete section. Normal operation under water logging condition on rail. Continuous monitoring of counts and health of SSDSC units. Error display by means of LEDs and error description on reset box. Easy to install, commission and maintain. Compatible to work on voice channel of OFCC and radio. 2 coils are used for direction determine purpose. 2 different frequencies are used to avoid mutual interferences. Now, schematic block diagram of SSDSC. It consists SSC card 1, SSC card 2, MLB card 1, MLB card 2, modem, relay drive card, DC-DC converter. Function of DC-DC converter card, that is card number 8. Its input and outputs are protected for short circuit and input reverse polarity. Input is 24 volt DC, outputs are 5 volt DC, 12 volt DC, 24 volt DC and isolated ground 15 volt. Signal conditioner card, that is card number 1 and 2. The signal conditioner card 1 SSC1 generates 21 kHz carrier signals which is transmitted to transmitter coil first. The signal conditioner card 2 SSC2 generates 23 kHz carrier signals which is transmitted to transmitter coil 2 always. These SSC cards receives respective induced modulated signal and demodulates it to generate valid train pulse. Microcontroller logic board or cards, that is card number 3 and 4. The microcontroller logic board MLB is the heart of system 2 out of 2 decision. train detection, checking, wheel detection, and counting functions. It receives the remote wheel count and computes the status of the section for clear or occupied. Event logger card, that is card number 5. It stores data from the remote and local SSDSC units. The stored data can be downloaded from the event logger card for the purpose of analyzing. Modem card, that is card number 6. The modem card transmits and receives the digital packets information from one counting unit to other. Relay driver card, that is card number 7. Relay driver card receives the command of clear and clock signals from MLB1 and MLB2 cards and drives the vital relay to energize condition when section is clear. If a train occupies the section, the vital relay is de-energized. Vital relay. This relay is driven by relay driver card. The VR relay picks up only when section is clear.